Short video to show the resin block being machined to act as a guide on a Kity woodworking machine. This is just to prove that the CNC program is correct with the job. The program is already loaded in the machine, just need to press a couple of buttons. The offsets are all set properly in the machine. It's taken a 10mm depth of cut early because it's set up to cut 7000 series aluminium, so the feed rates are reduced to suit that material and the depth of cut to suit the material. Could obviously be quicker with this resin block. You'd probably do it all in one depth. This is just a resin block to prove that the CNC is entered correctly. To prove the program before cutting the actual material, which is going to be 7000 series aluminium. So the cutting depths and feeds in this are set to suit that material, not the resin block. This resin block could be cut in one hit. There's 30mm depth of cut with one pass. This is the first operation on the block. This is now machining what's going to end up the top as top of the block. More will be revealed. You know it raised up there 10mm. That's because the cyclic part of the program includes a 10mm down feed. What it's done now is added a 0.2 cut as a finishing pass. The cutter is a 12mm diameter, 4 flute, high speed steel. RPM 1700, feed rate 100mm per minute. That's it. The tool is now stopped and it's returned to the starting point, which was rubbing the front left hand side and the front face that's closest to us. I now need to change the tool and the position of the block for the next operation. The block has been reset. The tool fitted now is a spotting drill, 6mm spotting drill, to spot the holes for the downward fixings. All the tool offsets are set. We close the door and start the program. So it moves over to the first hole and spots it, ready for the next drill, which is a 6.5mm drill. Stop for a tool change. I'll simulate the tool change to so it raises the head to give access to get the next tool in, which is longer. Now continue the program. That's a 6.5mm drill. This is the same size as the original block. This is acting as one of the 8 guides on a Kity woodworking machine. Just the resin model again to prove that the program is functioning correctly before cutting into metal. It's not always necessary because the program can be simulated in the computer to check for any errors, but it's sometimes preferable to prove the design concept before cutting metal. Now the tool is now moving to another position for another tool change. And the next tool is going to be a 12mm 4-flute cutter that we used in the first operation. What this is going to do is scallop the fronts out to allow spanner access to the hex-headed screws that retain the block to the machine. It's going down now 1mm, so it's onto the surface of the part. You'll see it just ends up putting a V shape around the axis of the block. I can show you that when I take it out. It'll be obvious to you. Now moving in to do the same operation on the other side. Feeds again are suited for aluminium. Could be faster with the resin block if we wanted. It's now moved over for another tool change, which is for the number 1 tool again for the next operation. The tool is now back to the point, the same tool as we started with, the program, and it's now back to the start position again, which is 1mm above the work and centred on the left hand back corner. I now need to reposition the block to cut the slots in the end to gain spanner access. The block is now set up in a different manner. It's got a 6mm tool in a chuck that's sent in a drill that's centred on the back left hand corner as before. This is going to drill a hole in the centre of the slot that's going to be cut later by the 8mm cutter when it's changed over. It's going to cut, it's going to drill to 20mm depth. It's drilling slow because it's set up to cut into aluminium, not into resin. It's operating in a peck cycle as well, so it's going to make it even slower. Bear with me. Probably going to do 3 packs, I would think. Now it's finished. Now I need to change the tool. It's now fitted an 8mm 4-flute cutter, high speed steel, to mill the slot. Press the program start again. Moves down, comes over 25mm. Now it will proceed to cut the slot. The idea of drilling the hole is because the cutter is not a centre cutting tool. It doesn't have flutes across the centre axis of the cutter, so it needs somewhere to, needs some assistance in getting the depth of cut. This is running in cyclic mode again. You can see it goes down, goes left, and goes right, and comes back to centre. It's now going to do a tapered cut at the end. The tool is moving to the left and rising at the same time to give an angled cut. It's actually set to give a 45-degree angle out of the end of the block. This allows the spanner handle to swing over far enough to turn the hexagon nut 60 degrees to tighten the block down onto the base of the machine. And that's that part of the program finished. There's one more part to come, which we'll get set up for and show you that as well. This operation is to cut a 20mm hole through the centre of the radius block. It's a 6mm 4-flute cutter. It has a pre-drilled hole. The machine speeds are set to run in aluminium, so it will be a fairly slow process. And close the door, zoom in a little bit so you can see what's happening, and start the program. Goes down into the block, now cutting a circular path, so the finished hole will be 20mm diameter. When this hole is being cut in the parts that are going to be made in the aluminium blocks, this hole will be bored in the lathe and a 4-jaw chuck, so it can be absolutely centred in the correct place. So all bores will be equidistant from the base, and correct in relation to the fixing holes. The bore will be precisely centre of the fixing screws and 20 millimeters diameter and 18 millimeters from the base to the centre, which is the same dimensions as the original pattern that was sent to do the copy from. You know that the tool comes back to the centre of the hole each time, so it can plunge down in the pre-drilled hole. This must be the last cut because the tool holder is practically in contact with the surface. And that's it. That's the block completed.